Hello, geometry. This is chapter 5.1. We're going to start today talking about perpendicular and angle bisectors and the perpendicular and angle bisector theorems. We're going to use those to solve problems. So the very first thing you need to know is you need to know the definition of equidistant. Equidistant points are the same distance, or points that are the same distance from another point. Okay, so equidistant, the same distance. Okay, so, and we're going to be talking about that as we progress. So let's talk about the perpendicular bisector theorem and how that relates, okay, to equidistant. So if a point is on the perpendicular bisector, so first off, a perpendicular bisector of a triangle is perpendicular to one side and it cuts that side in half. So if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So that means that this point P is on the perpendicular bisector, which makes these two, XP and PY, congruent. So here we have a problem. It says Mr. Lee wants to park his ice cream cart on Main Street. So he wants to park it somewhere here on Main Street. And he wants to park it so that he is equidistant from the entrances of the amusement park and the zoo. Where should Mr. Lee park and how can he determine where to park? Well, since we know that a perpendicular bisector is a point on a perpendicular bisector is the same distance to there and there, we need to create a perpendicular bisector. So to do that, I need to draw my segment. Okay, and I'm not going to measure. Normally we would measure. Okay. So we want to make sure that this is perpendicular and that it's in the middle, right? Because a perpendicular bisector cuts it in half. Okay, so that's a 90-degree angle, and that's, I didn't measure, like I said, but it's pretty close to equal. And so this point right here is going to be the same distance to both of those. So right here is where Mr. Lee needs to put his ice cream cart. Okay, so perpendicular bisector. So this one says, what is the value of WY? Okay, well, we see that this is perpendicular. We see these two symbols, which means we know that this is a perpendicular bisector. And if it's a perpendicular bisector, then we know that those two are congruent. So 5n minus 2. If XW is congruent to WY, that means their values are equal. So we know 5n minus 2 equals 2n plus 7. And now we're going to solve this. So subtract 2n from both sides. And I get 3n minus 2 equals 7. Add 2 to both sides. 3n equals 9. And I divide both sides by 3 and I get n equals 3. So that's n, but I wanted to know the value of WY. So from here to here. So now I'm going to plug that back in. So 2 times 3 plus 7. 2 times 3 is 6. 6 plus 7 is 13. How could we check this? Well, let's plug 3 into this one as well. 5 times 3 is 15. Minus 2 is 13. Okay, so that's one way that we can check it. So that's perpendicular bisector theorem. So now let's look at the angle bisector theorem. Your angle bisector theorem says that if a point is on the bisector of an angle, so here's this angle BAC, and it's cut in half by this ray AD. Okay, how do I know that? I know that because it's showing me that these two angles are congruent. So I know it's an angle bisector. And so if a point is on the bisector of an angle, so any point on this angle bisector, such as D, then it is equidistant from the two sides of the angle. Now keep in mind, the shortest distance to any point is a perpendicular line. So that's why when we talk about this distance and this distance being equal, we're always talking about the shortest distance. Okay, that's why it's perpendicular. So we know then that this and this are the same. So let's do a point then. or a problem. So it says if HI equals 7, so HI is 7, IJ is 7, and the measure of HGI, so this measure right here, is 25. It wants us to find the measure of IGJ, so IGJ. So we need to find this one right here. The first thing I'm gonna look at and notice is that these two have the same measure, and these are 90-degree angles, okay, which means that this is an angle bisector. If this is an angle bisector and this side is 25, this side also has to be 25 degrees. So the measure of angle IGJ is 25 degrees. I could take it a step further too. It didn't ask me for this here, but if I wanted to know the measure of angle HGJ, I could find that. Okay. So if this is 25 and this is 25, then I know that this angle measure is 50. I can also take it one step further, okay? If I were given some more information, which I'm not, but keep in mind that this picture right here has a right triangle in it. Okay? It has a right triangle. So this is a leg, this is a leg, and my hypotenuse is always across, okay, from my 90-degree angle. So I could even find some side lengths if I needed to. So that is all for 5.1. Have a great day, and I'll see you next time.